This short video discusses the purpose of an air dispersion model, the issues and the benefits. Firstly, I will go through some basics. Imagine a factory with a chimney stack, often referred to just as a stack or a point source. The stack will emit pollutants, for example, SOx, NOx or particulates. The pollutants will generally rise from the stack and level out, sometimes as a visible cloud. The pollutants will then dissipate over a wide area due to the wind and become less concentrated. At some point, the pollutants will fall to the ground. The actual concentration of a pollutant at ground level, termed the ground level concentration, will be made up of the background level, often called a background contribution, and that due to the stack, termed a process contribution. The background level can be found from data recorded by the EPA air monitoring stations, and there are a number of these around Ireland. The process contribution is calculated by the air dispersion model. One of the purposes of an air dispersion model is to determine whether the ground level concentration is within the ambient air quality standards. These air quality standards are set by the EU and define concentration limits for a range of common pollutants. The air dispersion model takes into account the effect of weather, for example wind direction and precipitation, cloud cover, atmospheric temperature, and the geography of the surrounding area. The height of the stack and of significant buildings are also taken into account. Using this data, the ground level contribution of the pollutants can be determined over a wide area. So, why would we need an air dispersion model? Often, a model is necessary as part of an environmental impact assessment. Where an organization wishes to change processes on site, often a model is required to show that there are no adverse impacts on the local area. An air dispersion model can be expensive. At least 3 years metadata is required, costing around €2,400. In addition, topographical data is required. A lot of computer processing then needs to be carried out and then the results interpreted. Due to the expense and time to run an air dispersion model, often an initial screening model is run. This model assumes the worst case weather and makes a prediction without the need to buy metadata. If the results from the screening model are acceptable, then there's often no need to go to the expense of running an air dispersion model with full metadata. So, what can you do if the results of the air dispersion model are not favourable? The most sustainable approach would be to see if the amount of pollutants emitted by the stack can be reduced, perhaps by changing the process or raw materials. Less sustainable options include installing abatement equipment, such as bag filters for particulates or scrubbers for acids and alkalis. Probably the least sustainable option is to raise the stack height. This will disperse the pollutants over a wider area. Often coal-fired power stations have some of the highest stacks. Environmental efficiency uses both screening models and full-blown air dispersion modelers to undertake work for clients. These include Screen 3 and AirMod. If you need an air dispersion model or want to know whether stack emissions from your site may be a problem, we would be happy to talk with you. And if you are still watching, a little bit about myself. I am Bob Sutcliffe, a Director of Environmental Efficiency. I'm a chartered engineer with experience in air emissions both in the UK and Ireland. I've previously worked on modelling power station air emissions at Warren Spring Laboratory and on engine emissions. Please feel free to call or email me.